Hello and welcome to another one of my Leetcode videos. In this one we'll do Leetcode 2306, today's daily challenge, naming a company. This is a hard problem, so yeah, let's hopefully try to simplify this as much as possible. So we have here basically an array of words, and these are considered ideas, right? So we can pick any pair from this array of words where in the case of the pair, if we swap the first letters of both of the chosen words, then none of those should exist in the array, right? So for example, in this case, if we choose coffee and donuts, if we swap the first two letters like Doffy and conuts, both of these words don't exist in the array, so this is a valid pair. In the other case where we have coffee and time, right, if we swap the first letters, we'll have toffee and kime, and toffee exists in the array, so this is not a valid pair, right? So we need to find in total how many valid pairs there are. So what will be our approach to solve this problem? We are given also that each word only consists of lowercase English letters, so this is something that we should use to our advantage, right? So basically, if you see, right, if any two words share a letter, right, let's say like time and toffee, they won't be able to be a valid pair, right? Because if you swap them, the other one will always exist in the array. And the other thing to note here is that anything which shares a suffix, let's say coffee and toffee, right? If they share a suffix, then they can't be a pair, because if you swap T and C, then the other one becomes, present in the array. So in that case also they can't be a valid pair, right? So, but also there's a special case where like if it's like T, which is time, even though it doesn't share a prefix or a suffix with coffee, but since there's another T as well, which shares a suffix with coffee, then that pair cannot be possible, right? So basically, we need to know everything that has T in it, right? And then we need to know everything that has C in it, and so on. And then we need to know all of the possible suffixes, right? So let's try to sketch this out. So what we'll do, our first thing we'll do is we'll group everything by the first letter and then just see how that works out, right? So we'll say like letter C has the suffixes offy, right? Letter D has the suffixes onuts. T has suffixes I'm and offy, right? And imagine we had another C like candle in the array as well, right? We have candle. So we have andle, right? So what we'll do is we'll take every pair. We'll say, okay, for we know that within this group there can be no pair, right? So we'll try to compare, okay, from group C and D, how many pairs can we form? So we have coffee and donuts, candle and donuts, right? And vice versa. So these are possible pairs. When we look at C and T, we know that, oh, since offy is in both of them, we can't pair any of them using this suffix, because if we choose this suffix, then swapping the letters would make the other one present in the array, right? So we basically have to first group them by first letter, right? Group suffixes by first letter. And then next, for each pair of letters, right? So for each pair of letters, we need to find the unique suffixes or non-overlapping suffixes, basically. So the suffixes which are not, overlapping, because coffee and toffee, these are overlapping, so we can't use this anymore. We just cancel it out, right? Then we're left with these two, and then these two we can use. So candle and time can be paired, right? And then so then for each pair of letters, we find the non-overlapping suffixes, and our number of pairs then will be equal to, non-overlapping suffixes in the set of the first letter. I'll just put at first letter times non-overlapping suffixes of the second letter, right? Because that's how many like words you can match from each group, right? And then since you can match both ways, right? So you can put candle and time, or you can put time and candle. We'll times this by 2, right? And that's how we'll get the total pairs. So let's go ahead and code that solution and see how this does. So first, let's create our, since we know that, that there can be no more than 26 um, letters, we'll just create a set of suffixes by letter, right? So this will be a set of strings, and the size of this set will be 26, right? It's an array of sets, right? So for each letter we have a set, and let's just go ahead and fill this set to an empty set initially. So I've initialized this to an empty set, and now we'll just loop through all of our ideas, and we'll insert into this set. So we'll just say suffixes at idea.car at 0. So this is the first letter minus a that will give us the index in the range of 0 to 26, and that will be in that set. We'll add the suffix idea.substring 1, right? And so now that we have the suffixes by letter, we'll just create this algorithm, right? So for each pair of letters, that means we need to go through all pairs. Now I'll just go through 1 to 26. This is like a fixed size, so it doesn't really matter much. You could also make this a map and then only iterate through the map key, so that's a bit more efficient, but for simplicity here we'll just do this. And note that the jth loop will start from I plus 1, because we don't want to compare the pairs twice, right? So we'll just compare each pair of letters once. So we have our loop set up. Now let's find the non-overlapping suffixes, right? So we'll take every suffix in like the ith one and look for it in the jth one, right? So we'll just say for string suffix in suffixes by letter at I, right? If suffixes by letter j contains that suffix, then we'll say overlapping plus plus, right? So we'll initialize overlapping to 0 here. And then what we want to do is pairs plus equals. So we'll initialize again pairs to 0, and obviously that will return. And at each loop, we'll say that pairs is the non-overlapping suffixes of the first one. So that's basically suffixes I dot size times non-overlapping of the second one, which is suffixes j dot size. Sorry, suffixes I dot size minus overlapping, right? Because we counted the overlapping ones, and so the non-overlapping of the first one are basically the size minus the overlapping, times, similarly for the second one, it's the size of the second one minus overlapping, and finally times 2, because we can pair them up in both directions, right? And finally we return pairs. So let's run this and see how this does. Oops, this is a typo here. All right, accepted. Let's submit. All right, one more bug here. We should use long here because the answer could exceed the number of pairs. So let's just update that and submit. All right, accepted. Thanks so much for watching. I'll see you in the next video. Cheers.